welcome back. In this video, we're going to look at applying problem-solving steps and using mathematical models. So in this section, we're going to apply what's called Polya's 4 steps in problem solving. And I recommend that you read through these different steps. The first step is just make sure that you understand the problem. Okay, so that might involve reading it a few times, making sure you understand what you're actually looking for. Devise some kind of plan. So after you read through the problem and you understand what you're looking for, come up with a strategy. That could possibly use inductive reasoning, looking for patterns, making tables or lists, estimating, things that we've talked about in the first 2 sections of this course. Try expressing the problem a little bit easier. You may have to use trial and error. List the given information in a chart or table. Making sketches or diagrams is sometimes helpful as well. Sometimes relating the problem to problems you're more familiar with also helps. That means making the problem a little bit easier for you to solve. Look for a catch, which is, when the problem involves some sort of a trick question deliberately intended to lead you in the wrong direction. You can eliminate those things, and then use given information to eliminate some possibilities, and also, of course, use some common sense. Ask yourself if your answer or the strategy you're using makes sense. The third step in Polya's 4 steps is to carry out the plan and solve the problem. And then the 4th step is always to check your answer. Does the answer satisfy the conditions of the problem? Does it make sense? Is it reasonable? If not, go back and check. You may have made a little error along the way, or maybe you need to, rethink how you're going to solve the problem. So let's practice some of those problem-solving techniques here. In this first problem, we're going to look at what necessary piece of information is missing and prevents you from solving the following problem. So the problem says a man purchased 5 shirts, each at the same discount price. How much did he pay for them? So I can't, use all 4 steps for this problem, but I can definitely use the first 2. And the reason I can't use the 4 is because we're missing some information. So I want to understand the problem first, right? So in other words, in this problem, what's my given? So what's given in this problem is they tell me that we have 5 shirts are purchased. Okay. Did they give us any other information? Well, they told us that each of the shirts were purchased at the same discount price. However, I'm not told what that discount price is, right? So that is definitely a missing piece of information, okay? If I use my second step, which is devise a plan, right? So how would I, in other words, figure out how much he paid for them? Well, the amount paid, right? How would I determine that? It would just be the number of shirts, which is in this case 5, times the cost per shirt. Okay, and again, I don't know the discount price. So the missing that prevents me from solving this problem is the discount price. You can try the next one on your own, and then you can unpause the video when you're ready to go over it. So what necessary piece of information is missing and prevents you from solving this problem? The bill for your meal totaled $20.36, including tax. How much change should you receive from the cashier? Okay, so let's understand the problem first. In other words, what's given here? Okay, so we're given that the total meal was $20.36, right? So that's important, and that also includes tax, something else that's important. They really didn't give me any other information, beyond that. So total meal is $20.36, including tax. Okay, so let's devise a plan now. How would I figure out how much change I would receive from the cashier? Well, I would need to know the amount of money that I would be giving to the cashier, right? Because they would take that amount and the total meal and subtract, and then that would leave me with the change. So the amount of change, which is what I'm looking for, is determined from the amount of money I give the cashier and then I'm going to subtract the total meal price. So what's missing is the amount of money given to the cashier. Okay. In the next problem, one more piece of information is given than is necessary for solving the problem. We need to identify what that unnecessary piece of information is, and then we have enough information to solve the problem. So it says a roll of Easy White paper towels contains 100 sheets and costs $1.38. A comparable brand, Quick Clean, contains 5 dozen sheets per roll and costs $1.23. If you need 3 rolls of paper towels, which brand is the better value? All right, so first let's understand the problem. What are we given? We're told that the Easy Wipes are 100 sheets per roll and it equals $1.38. Okay, and then I'm also told that the Quick Clean is 5 dozen sheets per roll and it's $1.23. And we need 3 rolls of paper towels. Okay, so let's come up with a plan, a strategy for figuring out which brand is the better value. So how would I find the better value? Well, I would want to compare the cost per sheet, right? Because each roll has several sheets. Easy Wipe has 100 sheets per roll, and then Quick Clean has 5 dozen sheets per roll. So they have a different number of sheets per roll, and they also charge a different amount for each brand. So to figure out which one's the better value, I'd want to find the one that has the lowest price per sheet, right? So the better value is just going to be the brand with the lower price per sheet. And what I would want to do is compare the brands by finding the cost per sheet for each. Okay. And we're going to divide by how many sheets are in a roll. And that's going to give me the price per sheet. So $1.38 divided by 100 is 0.0138. So if I round that, that's about 1 cent per sheet. Okay, I'm gonna do the same thing for the Quick Clean. I'm gonna take $1.23 and divide it by 5 dozen. So remember there's 12 in a dozen, so 5 times 12 is 60. So I'm gonna do $1.23 divided by 60, and that gives me 0.0205. So that's about 2 cents per sheet. Okay. So now, and that's the, if you look back at the A poly has 4 steps, right? That would be the solving portion of it. Okay, so we just solved the problem. Then we're going to check our answer. So this part here represents the solving part, and then we want to check. Okay, so how am I going to check it? Well, if I compare it here, the better value would be the 1 cent per sheet, right? So the Easy Wipe is the better. So let's state that first. So Easy Wipe is cheaper at 1 cent per sheet. Okay, and to check that, I'm going to just take the both of the prices I came up with. So right here, 0.0138. I'm going to multiply that by 100, and it should give me $1.38. And I'm going to take 0.0205, multiply it by 60, and it should give me $1.23, which they will, so you can check them. So both of them check out. So we know we computed the prices correctly, and we picked the Easy Wipe because it was a penny cheaper than the Quick Clean was. So what was the piece of information that was not necessary in solving the problem? So if you read the problem, the one thing that we really didn't need in solving it was that you need 3 rolls of paper towels, right? That doesn't really play into it because as long as we know which brand is cheaper based on the price per sheet in the roll, it doesn't matter how many rolls we need to buy, right? That doesn't factor into a brand having a better value. So the piece of information that's not relevant would be this part. Okay, it's not important. It doesn't prevent you from solving the problem. So what we found there was something called the unit price, which is, unit means 1, the price of 1 sheet in this case. So the unit price for the roll of Easy Wipe paper towels would be, 1 cent per sheet. The unit price for the better value would be 2 cents per sheet. So how did I find the unit price there? I just took the total price and I divided it by the total units. Okay. The word per is used to state unit prices. $1 cent per sheet or 2 cents per sheet. Okay, at this point you can pause the video and try this problem. Again, solving the problem but looking for information that's not relevant to the solution. A manufacturer packages its apple juice in bottles and boxes. A 128-ounce bottle costs $5.39, and a 9-pack of $6.75-ounce boxes costs $3.15. Which packaging option is the better value? So again, I need to understand the problem here. I'm looking for which packaging option is the better value, right? What did they give me? They told me that a 128-ounce bottle costs $5.39, and a 9-pack of 6.75-ounce boxes costs $3.15. So again, if I'm looking for which option's the better value, I need to look for the unit price, right? And I need to compare the bottle versus the box. So in solving the problem, right, for the bottle, let's talk about that. It tells us that it's $5.39 per 128-ounce bottles. And if I divide those, I get 0.0421 per ounce, so about 4 cents per ounce. If I look at the boxes, they told me that that's $3.15, and it's 6.75 ounces. And that comes out to 0.04667 per ounce. So which one is better? Well, if I round, this one's about 5 cents per ounce, and this one is about 4 cents per ounce. So the bottle is the better buy. Okay, and don't forget about the fourth step in Polly's method, which is check your answer. So to check it, I can multiply 0.0421 times 128, and it'll give me $5.39. And then 0.04667 times 6.75, and it'll give me 3.15. Okay. Now, which piece of information was not important there? Which part of the problem did we not use at all? And that was the fact that it was 9-pack, right? We don't really care about that. So that's the part that's not relevant. It doesn't prevent us from solving the problem. Okay. So in example number 3, by paying $100 cash up front and the balance of $20 a week, how long will it take to pay for a bicycle costing $680? So we're going to practice using Polly's 4 steps here. So the first thing is, what I need to understand the problem. So what are they giving me? So this is understand, right? What am I given here? I'm given the cost of the bike, which is $680. I'm given that the amount paid in cash was $100. And I'm also told that the weekly payments are $20 a week. Okay, so next I need to devise a plan, right? So what am I looking for here? How long is it going to take to pay for a bicycle that costs $680? So how would I determine that? Well, I know that the bicycle costs $680, right? I would want to subtract the cash that they paid up front. So it's the cost of the bike minus the amount paid in cash okay, and that's going to leave me with the amount left to be paid. Okay, but I'm not quite finished, right? So how would I figure out how long it would take me? So I'm looking for time, right? So the amount left to be paid, I would need to take that and divide by 20 because the plan is to pay $20 a week. So I'm going to take amount left to be paid. I'm going to divide that by 20. And then that's going to give me the number of weeks left to pay off the bike. Okay. So now I'm going to solve. And to solve it, we're actually going to plug in the numbers. So the cost of the bike was $680. And I'm going to subtract the $100. That leaves me with $580 was the amount left to be paid still. Okay, I'm going to take that $580 and I'm going to divide by 20 because they are paying $20 per week. So 580 divided by 20 gives me 29 weeks. So it's going to take 29 weeks for the bike to be paid off. I want to check it. So how will I check it? Well, I'm just going to go backwards. I'm going to multiply 29 times 20. And that's going to give me 580. And then I'm going to add 100, which would bring me back to the 680. So I know that that's correct. Okay, let's practice again. Suppose you're an engineer programming the automatic gate for a 50-cent toll. The gate should accept exact change only. It should not accept pennies. How many coin combinations must you program the gate to accept? Okay, let's understand the problem first. So what do they give me here? They tell me that the total change always has to be 50 cents, right? It accepts exact change only. Okay. Maybe one possible coin combination could be what? Maybe 2 quarters, right? That would give me 50 cents. 5 dimes would give me 50 cents. However, we want to remember no pennies. It says that in the problem. Okay, so we need to count all the combinations. So how can we do that and be organized? Well, we can maybe make a list. All right, so for the solving part, I'm going to make a list. I'm going to start out with the highest denomination of coin, because it takes coins, right? It's 50 cents. So a $50 is 50 cents, right? And then we have quarters, and then underneath that dimes, followed by nickels, and remember there's no pennies. All right. So I'm going to go through and I'm going to figure out how many of each denomination I would need. And remember, it has to add up to 50 cents. So a $50 is already 50 cents. So if I had a $50, I could get in the gate. I wouldn't need any of those other combinations. Okay, so that's the only combination I could use with the $50, right? Because it is 50 cents. So what else could I do? I could do 2 quarters. And then I wouldn't need any of these other denominations. Sticking with quarters only, I could do 1 quarter. That would give me 25 cents. And then maybe I could do 2 dimes. That would give me another 20 cents. So that's 45 cents plus a nickel. There's your 50 cents. I could do 1 quarter, and maybe instead of doing 2 dimes, I could do 1 dime, right? That would give me 35 cents, and then I would just need 3 nickels for 15 more cents. 35 plus 15 is 50. I'm still not done with quarters. This time I could use 1 quarter and 0 dimes, and I would need 5 nickels. Or, and of course these are zeros, right? So we're not going to have any more $50. I think I'm done with my quarter denominations. Now I could do 0 quarters, maybe start out with 5 dimes and then 0 nickels. Okay, and then I would need 4 dimes and 2 nickels. 3 dimes, so that's 30, and then 4 nickels. 2 dimes, that would be 20 cents, and then I need 30 cents more, so 6 nickels. 1 dime and 8 nickels, and then of course 0 dimes, and I could just have 10 nickels. And the rest of these are just all zeros, right? So how many different combinations is that? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 combinations that would add up to 50 cents. Okay, and of course you could always check it. You would have to check each one though. So $1/2, 50 cents. For the next one you could do 2 times 25 cents plus zeros for the others, so you don't even need the plus, and that's 50 cents. Okay, you could check another one, like here, you've got 2 and 6, so 2 dimes plus 6 nickels, so that would give me 20 cents plus 30 cents, and remember, it's just got to add up to 50 cents each time. Okay, so you would just want to check real quick, make sure that adds up. Okay, so we're good. I'm going to leave the next one for you all to try, but I will tell you that the answer is 5 combinations. All right, in my next problem, I have 4 runners are in a 1-mile race. We've got Maria, Aretha, Thelma, and Debbie. Points are awarded only to the women finishing first or second. The first place winner gets more points than the second place winner. How many different arrangements of first and second place winners are possible? Let's understand the problem first. What do they give me? They tell me that we have our 4 runners, right? And the first place winner gets more points than the second place winner. And points are only awarded to women that are finishing first or second. We're looking for how many different arrangements of the first and second place winners are possible. So there's 3 possibilities for first and second positions. Okay, for example, let's say, and this is just one scenario, right? It could be Maria came in first and then Aretha came in second. Or Maria came in first and Thelma came in second. Or maybe Aretha came in first and Maria came in second. Okay, so these are not the only options, they're some of the possibilities. We need to figure out all of them because we need to know how many different arrangements of first and second place winners are possible. So let's start with Maria then, right? Here's our plan. If Maria finishes first, each of the other 3 women could finish second, right? Okay. So I need to figure out all the possibilities, right? And I need to be organized again. You can make a list. I'm going to make what's called a tree diagram. So let me show you what that is. We use tree diagrams a lot when we're looking at probabilities and we're looking at what's called the counting principle. So that's something that, we'll discuss later in the, in a whole other course, MGF 1131. It used to be in the old MGF 1106, but has now moved. So when I'm solving this, let's make a little organized 2 columns here. We've got first place and second place. Now, I need to keep in mind any four of those women could be in first place. So Maria could be in first at some point, Aretha could be, Velma could be, or Debbie could be, right? So any four of them could be in first. But whoever's in first obviously can't also be in second. So if Maria finishes in first place, then that means Aretha could be in second, Velma could be in second, or Debbie could be in second. If Aretha finishes first, that means that Maria could be in second, Velma could be in second, or Debbie could be in second. If Velma finishes first, then Maria, Aretha, or Debbie could be in second. And if Debbie finishes first, it's Maria, Aretha, or Velma in second place. So how many different combinations or possibilities are there? Well, I could have Maria and Aretha. So Maria would come in first, Aretha second. Or it could be Maria first and Velma second. Or Maria and then Debbie, and so on. So here's a list of all the different possibilities, which you can see is very organized when making the tree diagram. And if I go through and count those, it leaves me with 12 possibilities of first and second place. And of course, to check it, we'd want to make sure it's reasonable. Like, is there a pairing of each woman with another woman on that team of four? And there is, because you've got Maria, and then there's her three teammates, and then here's Aretha, and then her three teammates, and so on. So that is a reasonable answer. I'll leave the next problem for you all to try. And the answer that you should get is 6 outfits. Okay. Here's another problem for you all to try. And in this problem, making a table is the easiest way to do this. So I'll tell you that the answer here should be A, C, E, D, B, and A. And I'll start you off and give you some hints when you're solving this. A sales director who lives in City A is required to fly to regional offices in cities B, C, D, and E. Other than starting and ending the trip in City A, there are no other restrictions as to the order in which the other 4 cities are visited. The one-way fares between each of the cities are given in the table below. A diagram that illustrates this information is also provided. So this is a graph. It's kind of a network, and it's showing you basically like we're starting at A and then we're going to all the destinations. So it's telling you like if you want to travel from city A to B, it's $180. Or if you want to go from A to C, it's $114. Or if I wanted to travel from like E back to A, it's $128, and so on. So you can kind of see like a connection there between the cities and then their airfares. So give the sales director an order for visiting cities B, C, D, and E once, returning home to city A for less than $750. Okay, so the first thing I want to look at here is if I'm starting out in A, right? What would be the cheapest city to go to from A? So if I look at the table, I can see that if I want to fly from A to city B, it's $180. But if I want to fly from A to C, it's $114. And that's the lowest of the 4, right? So from A to C, I know that that's going to give me the cheapest airfare, which is $114. Okay? So now I'm in C, so now I have to figure out, okay, C to what city would also be the cheapest? So if I'm here in row C, right, and I look, I don't want to go back to A yet because it's not the end of my trip. I need to go from C to another one of these cities. And if I scan this, not including A, right, E would be the cheapest out of these cities that I need to pick from. So I'm going to go from C to E now, which is $115. And remember, I need to make sure that the total is less than $750, but so far I'm on track for doing that. Okay, so now I'm in city E, and so I'm down here, and I'm not going to go back to A, so I can't look at that one. And I'm not going to go back to C, because I already used that one. So if I'm at E, the cheapest to go to would be D between the two, right? 194 is smaller than 195. So I know that that's $194. And I'm going to continue on until I make it to back to city A. So far we visited, we've been in A, we've been to C, we've been to E and D, right? So now you have to figure out how to go from D to B, and then you're going to go from B back to A. And that should lead you to the total, which should be less than $750. And you can check it by adding up the prices. Now, for this next portion of the notes, I would encourage you to read through these directions, but basically you're going to be divided into groups of 2 to 3. So if you're in my online class, you will be given an email with your groups. And just think of your groups as like, a collaboration team. And all you need to do is collaborate with them. You will be assigned one word problem, okay? And you're going to need to solve this problem applying Polya's method at some point before you take the test. So now I know the directions say within the first part of class, but if we're in an online setting, we don't really meet, right? So at some point between you doing this video, which should be prior to the test, right, well in advance, you're going to hopefully get in touch with your group members, and you're going to collaborate to solve the problem that you're assigned. Only one person in the group needs to submit the problem per group or pair. So to prepare for that portion of the test, you can practice these problems. There's 7 or 8 problems here, and there's hints that go with each one. And this goes along with different problem solving strategies that you might need to use when you're solving any type of problem. So it kind of, it's an extension of Polya's method, okay? So these are good practice problems. You're not required to do them, but I would encourage you to try each of them so that you get an idea of how to work these problems out and to feel more prepared for the problem you'll be assigned on the test. The problem that you're assigned on the test will count as 50% of your grade, and then your test is going to count for the other 50%. If you have any questions, please reach out to me, but I really encourage you to practice these problems. Word problems are not easy for many people, but they're very practical and applicable, and they will really help you to become better problem solvers. But however, please reach out if you do struggle or have any issues, and we can work together. But have a great rest of your day, and thanks for paying attention.